Today we are going to divide rational expressions. Honestly, dividing rational expressions is not any different. It's still going to be a bunch of factoring. The only thing is we have to rewrite the problem at the beginning before we start factoring. So in math, dividing fractions is kind of a no-no. It's a little bit messed up. So instead of dividing fractions, we're going to multiply by the reciprocal. So this phrase, multiply by the reciprocal, you might recognize this as KCF. Keep, change, flip. Have you ever heard keep, change, flip before? I feel like you have in previous classes heard keep, change, flip. Keep, change, flip means keep the first fraction the same. Change the sign to multiply. And flip the second fraction. Multiply by the reciprocal means keep, change, flip. We keep the first fraction the same. So we've got 5x over 3x minus 12. Change the sign to multiply, and we're multiplying by the reciprocal. Reciprocal means you flip the fraction. So that second fraction we're going to flip. It's going to be x squared minus 6x plus 8 on the top, and x squared minus 2x on the bottom. So keep the first fraction the same, change the sign to multiply, flip the second fraction. Once we've done that step, now this problem is exactly like what we did yesterday. We have two numerators and two denominators. We need to factor everything that we can possibly factor and then cancel things out. So I'm going to put one big long line. I'll start with 5x. Can we factor 5x? Nope, it's just a 5x. Then I've got x squared minus 6x plus 8. We're looking for two numbers that multiply to give us 8 and add up to negative 6. I feel like that would be 2 and 4. It'd have to be negative 2 and negative 4. If you need to write the blanks out to see that better, that's totally fine. Oftentimes I don't write those blanks out anymore. 3x minus 12. I think a lot of people yesterday were struggling with greatest common factor factoring. So this is greatest common factor. It's two terms. It's not difference of two squares. What do 3x and 12 have in common? We can divide them both by 3. 3x divided by 3 is x. 12 divided by 3 is 4. So it's 3 times the quantity x minus 4. And x squared minus 2x. It is x squared minus, so you think it might be difference of two squares, but 2x is not a perfect square. So this is also greatest common factor. These two terms have x in common, leaving us with x minus 2. Now my favorite part, where we slash the things that are the same on the top and the bottom. I see x minus 2. I see x minus 4. Anything else? This 5x is not really 5x. It is 5 times x. So the x will cancel. And our end result is 5/3. Would you all agree that 5/3 is a little bit simpler than what we started with? Just a little bit. All right, I would like you to try number 11 on your own. We'll start it together. We need to keep the first fraction the same, change the sign to multiply, flip the second fraction. Now on your own, factor, 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 cancel, 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 however many times. Once it's all factored, X minus 2 cancels, x plus 3 cancels. This time the x doesn't cancel because we don't have a factor of x on the top. So our final answer is 3 over 4x. Number 12, before we keep, change, flip, we need to make sure that we actually have two rational expressions, two fractions. So this 4x squared minus x, that is a fraction if we put it over 1. So keep the first fraction the same. Change the sign to multiply. And now because we've made that second one a fraction, we can flip that one and put the 1 on top and the 4x squared minus x on the bottom. If we were actually going to fully do this problem, this first trinomial, do you notice anything different about this trinomial? There's an 8 in the front, and we can't divide them all by 8. We can't divide them all by 2. This is the type of factoring problem where you would have to multiply the 8 times the negative 3. So you'd be looking for two numbers that multiply to give you negative 24 and add up to 10. And then you'd have to do the factor by grouping. So this would take a little bit more work to get it factored. Looking at your assignments, you don't have any problems like this, and I am not going to put any problems like this on the test. So if you remember, there is a way to factor this, but that's really going back to can you factor or not, rather than what we're currently doing. So we at least got it set up, so if you ever encounter that kind of a problem, you know how to set it up and factor it. Do we need to do number 13? Number 13 is basically a two-part problem. Part 1, we need to multiply those two. And then part 2, we need to do the division problem. So this one is actually already factored, at least the first part is. So we've got x and 4x plus 1 over x plus 3. That 4x plus 1 is over 1, so x and 4x plus 1 are both numerators. Then, instead of the division, we are going to multiply and flip the second one. X plus 3 I put in parentheses because there's no, we can't factor that any more than it already is. The only thing here that needs to be factored is 16x squared minus 1. That is a difference of two squares. 16x squared is the perfect square of 4x. 1 is the perfect square of 1. So if I were going to write all of this out, we've got x, we've got 4x plus 1, we've got x plus 3. On the bottom, we've got x plus 3. And then that thing factors into 4x plus 1, 4x minus 1. Start canceling. Ta-da. On worksheet number 5, just be careful to look at the symbols. Numbers 1 through 4 are division problems like we learned how to do today. Number 5 and 6 are review problems. Those are already multiplication. So you don't need to do keep, change, flip on 5 and 6. You only need to do keep, change, flip on numbers 1 through 4.